All right, guys, let's go ahead and get out our handy dandy formula book so that way we can go through this review and it goes nice and smooth. Number one, what is an arc? And I'm going to type these answers because my handwriting, especially on my laptop, is not the best. So what is an arc? We talked about how it's a piece of the circumference. What is a sector? It's also a piece. It's a piece of the area. What is the formula for circumference? Remember, there's two of them. It was C is equal to 2 pi r, or C is equal to pi d, or d pi, same thing. And then, unfortunately for area, there's only one formula, and it's pi r squared. Number 5, determine the arc given the angle. So what we're going to do is we are going to trace the angle to see what arc is attached to it. So we have f to x to t. If you notice, that turns out being a semicircle, so there's lots of different answers we could have. And remember, an arc, which is what we're asked to describe or name, goes around the circle, not through it. So we could have f, q, t. Or we could have f, d, t. Or some variation. Remember, we can go backwards and forwards in the same thing. Next, we have BPM. And this one has lots and lots and lots of different answers, but I think we're going to only go through 3. So the first one we could do would be BM, because if you notice, it's not a semicircle, it's a minor arc. So because it's only a minor arc going B to M, I only need 2 letters. However, if I go the opposite direction, it would be a major arc of BLM, for example. Or I could say BWM, and any variation of that. Next, we're determining the angle given the arc. So if I am given Q to F to D, what arc creates that angle? I'm sorry, what angle creates that arc? Right there. Angle QXD, or we could go DXQ. Remember, when naming an angle, the center needs to be in the center. Next, I have G to L to W. If you notice, that angle's right there. And we have GPW. Determine the circumference. Now, this is where it's going to differ. Accelerated, you're going to leave yours in terms of pi. Regular, you're going to go ahead and type it in your calculator. So I'm going to put both answers. So with circumference, I need 2 pi r or pi d. So I'm going to go ahead and take 15 times 2, which gives me 30, times pi, which is 94.25. And it's in terms of feet. And since we're dealing with circumference, it would just be feet. Number 10, I need the diameter, so I have it, so 14 pi, which is 43.98 inches. Area, however, you only can use the radius. Remember, it's pi. I need that pi symbol first. R squared. So I have 5 as my radius, so 5 squared is 25. Which is 78.54, and it's meters squared. On 12, my diameter is 20, but I only need half of that, so I'm going to use 10. And remember, 10 squared is just simply 100. which is 31416 centimeters squared. Number 13 and 14 are asked to find the length, so that's going to be following our circumference formula. So I'm going to go ahead and take the degree I'm given, which is 215, divided by 360, times my radius times 2, or my diameter. In this case, I'm given the radius, so we need to multiply that by 2, times 10. Which is 215 pi over 360, or 18.76, and then feet. Next, in number 14, I have my degree of 90 over 360 times 2 times my radius times 5. Which is 3 pi over 2, or 4.71. And that has inches, and I'm running out of room. Number 15, area. Area is going to be in squared units. So I have 165 divided by 360 times, well, I have the diameter of 16, half of that is 8, so 64 pi. Which is 88 pi over 3, or 92.15 centimeters squared. Then on 16, I have 145 over 360 times 36 pi. So 29 pi over 2, which is 45.55 centimeters squared. "17, find the value of x, assume anything that looks like tangent is tangent." So I have a circle. How many degrees is a circle? 360. Great. How many different triangles can I make like this? So I have 1, 2, 3, 4, 5, technically, right? There's 1 here, 2, 3, 4, 5. So I'm creating equal triangles, and I have 5 equal triangles. So I'm going to take that 360 divided by 5. So each angle is 72 degrees. Not too complex. 18's a little bit more complex. So again, it's telling me to assume that it's tangent if it looks tangent. So I'm going to pretend that there's a 90-degree symbol there, because if it's tangent, that definition tells me that tangent lines create perpendicular angles. So I have my Pythagorean theorem, so leg plus leg squared is equal to the hypotenuse squared. Now hypotenuse is x plus 2. That little piece up top is x. This little piece down here is 2, so the whole thing is x plus 2. So I'm going to have to do some FOILing. So I have x squared plus 64 is equal to, well, I know that needs to be a second one there. Oop. Just trying to close my parenthesis and it moved my thing. X times x is x squared. X times 2 is 2x plus 2 more x plus 4. So I have x squared plus 64 equals x squared plus 4x plus 4. I'm going to go ahead and subtract the x squareds out, and they're both gone. So I'm left with 64 is equal to 4x plus 4. I'm going to subtract out 4, so I'm left with 60. And then 60 divided by 4 is 15. So x is equal to 15. All right, last two. So this one we're asked to find the value of x, and x is this distance right here. It's that last tangent spot. So I need to go around and find the other ones in order to figure that out. So if this one's 6, this one's 6. If this whole thing is 9, sorry you can't see what I'm showing you. If this whole length is 9, and this piece here is 6, 6 minus 9 is 3. So this piece has to be 3. And again, this piece would have to be 3. And if the whole length is 8, and that little piece there is 3, this has to be 5. So x is equal to 5. Now on 20, it's the exact same picture, but it's asking me for the perimeter. So we just determined this little piece was 5. So 6 plus 5 is 11, plus 9 plus 8. So this gives me 20, plus 8 more is 28. And it's got units, so it's in units. I hope you guys are ready for your quiz tomorrow. Make sure you study.